Today we're going to be focusing on scatter plots and line of best fit. We started into this on Friday with taking a scatter plot and calculating the line of best fit, but now we're going to use it to make predictions. So the table below shows the predicted annual cost for a middle-income family to raise a child from birth until adulthood. Draw a scatter plot and describe what relationship exists within the data. Now, you'll notice from the scatter plot here, I've gone ahead and put the dots onto the graph. Yes, I realize that none of these say 10,000, 11,000, 12,000, but each value on my y-axis is representing 1,000. So I have 4,000, 8,000, 12,000, 16,000, which makes it a little bit easier to graph. Now I want to find my line of best fit. And since I'm using a computer and you're using a piece of paper, remember you'll set up a ruler over top of your data points and try to get your data to go through, or your line to go through your data as best as possible. Now, when I stop on a whole number such as 8, it becomes a little trickier. That doesn't quite look like it's a well-balanced line to go with the direction of my data. So as I continue to manipulate this line and move it around to where it seems to go through my data best, yeah, I think I'm happy with that. It's touching 4 of my points and leaving off the one low one, but that seems to be a relatively close line of best fit for this set of data. So, let's calculate what this line actually is. We learned from our previous unit that anytime we have 2 ordered pairs, we can calculate a line. And so, I have one ordered pair that is 2, 10. I have another ordered pair that is 14, 16. And so we're going to use our slope formula. M is equal to y2 minus y1 over x2 minus x1, where my y2 value is 16 minus my y1 value of 10 over my x2 value of 14 minus my x1 value of 2. So 16 minus 10 gives us 6. 14 minus 2 gives us 12. And that's going to simplify to 1/2. Well, we now know that the slope is 1/2. So we're going to start with our slope-intercept form and use one of our 2 ordered pairs to plug in the values we know. Now, I like 10. It's a nice clean number, so we're going to deal with that one. Using our top ordered pair and our slope, we want to know a line that goes through that ordered pair with this slope. So replace the y with the y value. 10 equals 1/2. Replace the x with the x value plus b. 1/2 times 2, that's 1. And we subtract 1 from both sides. And so now we have determined that our b value is 9. We have come up with the equation y equals 1/2 x plus 9. Now I know that the software on the screen gives you an equation that is more precise to this line given the values that it knows where these are seated. But since we're calculating this by hand, we're going to use our equation, y equals 1/2 x plus 9. And then we want to see, it may even let me. Then we want to see the actual line of best fit and see how close we got. The actual line of best fit was y equals 0.51 x plus 8.75. We were really, really close. Now, the nice thing about being really, really close is really, really close will get you close approximate predictions. When your equations are further apart, your prediction is going to be further off. So now let's make some sort of prediction from this. Let's suppose that we wanted to know the cost of raising an 18-year-old child. Based on the data, our age has been our x value on our graph. And since it's our x value on our graph, it will also be our x value in our equation. And so we could plug in what we know. Y is equal to 1/2 of 18 plus 9. Well, 18 times 1/2, that's 9, plus 9 is equal to 18. Now remember, our y values were in terms of thousands, so this is really $18,000. And that's how we take what we learned on Friday and we apply it in a way that's going to allow us to make predictions. Remember, your predictions may be slightly off, so we'll go ahead and say that these are approximate values. And you should be able to follow this same type of pattern to complete both the classwork and the homework.